The UK Energy Research Centre has a special place, I think, in the Research Council's Energy Programme, because we were set up about 5 years ago to take a whole systems approach to energy. Some people might look at one bit of the energy system or one technology, like carbon capture and storage or nuclear. What we're asked to do is look at the energy system as a whole and how the different parts interact with each other so that we take a consistent view of the whole energy system. We have divided the work into 4 different themes. So one of the themes is looking at energy demand and how you can manage energy demand, hopefully to reduce it. There's another part looking at energy supply and infrastructure. So that's things like nuclear, renewable energy and the electricity and gas grids. We've got a theme on energy and the environment, where we're looking at the environmental impacts and consequences of different paths of development for the energy sector. And then we have a final theme that is called energy systems, which really is the people who try to put it all together, mainly by using big computer models that try to simulate the way the energy system operates. We're asked to take a whole systems approach, so we're funded by the Engineering and Physical Sciences Research Council, the Natural Environment Research Council and the Economic and Social Research Council. And that means that the UKERC people are actually coming from a very wide range of disciplines. The Committee on Climate Change has made use of UKERC's modelling capabilities to inform their analysis, and a number of the people who are involved in UKERC have actually carried out contracts for, say, the government or the Committee on Climate Change to help them with their analysis. The big theme in the environmental area for the UK Energy Research Centre is climate change and the drive to reduce carbon dioxide emissions, and it is a major organising principle behind our work. But what's important for us is not to neglect the other environmental impacts of the energy system at the same time. For example, if there's a lot of biocrops coming into the system, what are the environmental implications of that in terms of land use or water use? If you were to use biomass as a fuel for home heating, there are some interesting issues around air quality. But also the marine environment's becoming increasingly important, A, because of the amount of renewable energy that we may have offshore, and secondly, because carbon capture and storage may involve putting carbon dioxide back into old oil and gas wells in the North Sea, so there's a marine dimension to that as well. The biggest challenge really is getting an energy system that's compatible with a world in which climate change doesn't run away with us. It's a challenge that will never go away. We've got decades of work to actually carry out here. It may go in and out of fashion as time goes on, but for the kind of PhD students that we are bringing through at the moment, we hope it's still part of their professional life, when they're as grey-haired as I am.